This is week 6, day 4 of our lesson, and we will be talking today about the intercepts, zeros, and asymptotes of exponential functions. Let's start with the intercepts. Functions have x and y intercepts. With regards to the y-intercept, this is the value where the graph crosses the y-axis. For example, in our given function, we have f of x equals 2 to the power of x minus 2, and this is its graph. This is the y-axis, and this is the x-axis. If you have noticed, the graph crosses both the y-axis and the x-axis. And since we are looking for the y-intercept here, this is our y-intercept, the value -1. In an ordered pair, the first value is the abscissa while the second value is the y-coordinate. And this value is our y-intercept. To solve for the y-intercept, evaluate the function at x equals 0. So using the same given, we have f of x equals 2 to the power of x minus 2. When we evaluate, we replace all the x's with 0. Now 2 to the power of 0 is, of course, 1, and 1 minus 2 is equivalent to -1. If we compare it to our graph, indeed, the y-intercept is -1. With regards to the x-intercept, this is the value where the graph crosses the x-axis. It is also known as the zero of an exponential function, and this refers to the value of the independent variable x that makes the function 0. Graphically, the zero of an exponential function is the abscissa, or the first value, or the x value, of the point of intersection of the graph of the exponential function and the x-axis. So going back to our given function earlier and its graph, this is our x-intercept, since in this point the graph crosses the x-axis. This is also our 0. To find the zero of an exponential function x, equate f of x to 0 and solve for x. So for instance, we have the given function. We replace f of x with 0 so that we will be able to solve the value of x. Now we transpose -2 to the other side. We have 2 equals 2 to the power of x. So that we will be able to get the value of x, we need to make sure that they have the same bases, and 2 is equivalent to 2 to the power of 1. Now x is equal to 1, and this is indeed our x-intercept, at the same time the zero of our exponential function. With regards to the asymptote, it is a line that a graph keeps approaching but never touches it. Exponential functions always have a horizontal asymptote given by y equals 0. However, take note that this horizontal asymptote, y equals 0, is limited only to exponential functions without shiftings, particularly the horizontal shiftings. For instance, we have this given function, f of x equals 2 to the power of x, and this is its graph. If you have noticed, as the graph takes more negative values, the graph also approaches to the line y equals 0. Therefore, this is our horizontal asymptote. You have to remember that exponential functions do not have any vertical asymptote. It's always none. Let's consider another example. We have f of x equals 2 to the power of x minus 2. So this is its graph, and as you have seen, the graph approaches to the line y equals -2. Therefore, the horizontal asymptote is the line y equals -2. But I'll share you a technique. Even though there is no graph presented, you will still be able to identify the asymptote of exponential functions. How? the number that comes after this expression, there is the base and an exponent variable. This number here is the horizontal asymptote. Any number that comes after the expression, the base with an exponent variable, is our horizontal asymptote. So as easy as that, you don't have to graph anymore. You can identify the asymptote of exponential functions. Let's have some exercises. So we only need to determine the intercepts, zeros, and asymptotes. Let us start with the first one. F of x equals 3 to the power of x. To determine its x-intercept, replace f of x with 0 and then solve for x. And since we cannot find any value that can make the function 0, therefore there is no x-intercept, there is also no 0. But for its y-intercept, evaluate the function at 0, replace all the x's with 0. So 3 to the power of 0 is actually equal to 1. Therefore, the y-intercept is 1. Let's compare it with our graph. Indeed, it crosses the y-axis at point 1. And if you have noticed, the graph did not cross the x-axis. Therefore, it has no x-intercept. It has also no 0. With regards to the horizontal asymptote, the graph approaches to the line y equals 0. That is our horizontal asymptote. And again, there is no vertical asymptote. Let me give you another example. F of x equals 2/3 to an exponent of x. The same process for the x-intercept. Again, there is none. There is also no 0 since we cannot find any value that can make the function 0. For its y-intercept, the same process that we had a while ago. Replace all the x's with 0. And 2/3 raised to an exponent of 0 is 1. Therefore, its y-intercept is also 1. And this is its graph. As you have seen, the graph crosses the y-axis at 1. There is no x-intercept as well as no 0. And the horizontal asymptote is the line y equals 0. There is no vertical asymptote. Is it clear to you now? Let me present to you another example. F of x equals 2 raised to an exponent of quantity x minus 2. Take note, the exponent has an extension, it's minus 2. So for its x-intercept, again there is none. For its y-intercept, replace all the x's with 0. And 0 minus 2 is negative 2. So to evaluate 2 to the power of negative 2, apply the laws of exponent, particularly the laws of negative exponents. So that is equivalent to 1 over 2 squared. We take the reciprocal and then the sign of the exponent becomes positive. And as we evaluate it further, the value is 1/4. Therefore, the y-intercept is 1/4. And this is its graph. So at the value 1/4, the graph crosses the y-axis. There is no x-intercept, there is also no 0. For its horizontal asymptote, still it's found on the line y equals 0. And there is no vertical asymptote. If you have noticed as well in the given function, ang sumpay nga negative 2 is an exponent, dili another expression. That's why the horizontal asymptote is the line y equals 0. I believe you already have understood the lesson, but let me present to you the last example. F of x equals 2 to an exponent of x plus 3. This time around, we have an extension, and this number here is not an exponent. Therefore, without even having the graph, we know that 3 is its horizontal asymptote. So let's check it later on. So for its x-intercept, there is none. There is also no 0. For its y-intercept, evaluate the function at 0. We have here 2 to the power of 0 is 1, and then added to 3, that is 4. Therefore, the y-intercept is 4. Now let's compare it to our graph here. So you can see that the graph crosses at this value. This is our y-intercept. There is no x-intercept. There is also no 0. And with regards to the horizontal asymptote, I've mentioned earlier, indeed it's the line y equals 3. The graph keeps on approaching on this particular value, but it will never cross on that value. And as I've mentioned earlier, kung say sumpay diri nga dili exponent, it is the horizontal asymptote. That is why it's the line y equals 3. And there is no vertical asymptote. So that is how to determine the intercepts, zeros, and asymptotes of exponential functions.